Hey everyone, how goes it? And welcome back to Computer Science 145. Today, we're going to continue discussing classes and objects. We're going to focus today by going over a big example. This is going to go over everything that's been discussed so far and introduce some brand new concepts. First, let's establish the problem that we're going to solve. I like to travel around, and while I like to travel around, I like to enjoy one of the world's most perfect foods, a taco. The problem that we're solving is we need to keep track of the tacos that I like. Now, the whole purpose of everything that we've been doing is we are creating solutions to problems by using the tool that we call a computer. We are creating programs, we are creating software in order to address these problems. There's a lot of different ways that we can start engineering software, and there's many different models for creating software. One of the most classic models for software engineering is called the waterfall model. Now, before I go into it, I have to address that there are a lot of different software engineering models, and I recommend looking into a variety of them. But for right now, let's keep it simple by going over the waterfall model. It consists of a couple of steps. First, gather your requirements. Next, design the software. Next, implement the software, in other words, code it. Next, verify the software by testing it, and then maintain the software. Now, in order to address our problem, we're going to go through these steps. First, let's gather our requirements. What does this software require? Well, it needs to keep track of important taco information. What kind of information? Well, the taco's name, location, and its price. The software should be able to add tacos, remove tacos by a given name, sort the tacos by price, and display all the taco information. In addition to all of that, the software should have a clear and simple front end that the user can use. Now that we have our requirements, we move on to designing the software. One important design decision that I highly recommend is to always separate the front end from the back end. The front end is how the user interfaces with the software, and this can include graphical user interfaces or command line interpreters, just like the console. The back end is the part that has all of the functionality, and what we want to do is create a nice front end, that way we can use the back end functionality to work. From there, we can start designing the software by using a UML class diagram. This Unified Markup Language class diagram consists of a couple of parts. First, you have boxes, which are structures just like classes. Now also, you have arrows that show the relationship between the structures. So it shows the relationships between the classes. How do they work together? Now, in a UML class diagram, whenever we're creating this type of class, what we have are a box with a couple of different sections. The first section is the identifier of the class. This next section are all of the properties, such as constants and instance variables. The next section are the methods. So these are the actions that this class will do. Now you also have arrows to indicate the relationship between these classes. Whenever you have an arrow like this, and we're going to refer to this as the stick arrow, this is called an association, or the has a relationship. Whenever you see this, you usually have some sort of numeric value that indicates the number of instances of that class. So the way to think about this is this class has instances of that class. Now, in addition to all of that, static variables and methods are underlined, and you can always tell a constant because the identifier is uppercased. Using this concept, we're going to start designing the software to address this problem. As it's been brought up before, you can always think of a class as being a noun. What is the most obvious noun that we've been addressing in this problem? Well, a taco. We're going to have several instances of this class taco. So now what we need to do is start designing this class. And as we have right here, we have a UML class diagram where the first box indicates the identifier of this class. Now this middle box indicates the properties. This is the information that we're keeping track of. So what information do I need to know about each taco? Well, its name, its location, and its price. Now notice when we're designing this, there are some special symbols, and I'm going to show how to read this. First, you may notice this minus sign. This indicates that it has a private scope. So as these are instance variables, it's been recommended that you create their scope as private. That way we adhere to encapsulation. And the way that we would read this is simply private string name, private string location, and private double price. Now below that we have the methods. What are the actions that this class is going to do? Remember that methods are the verbs. And so if you think of the class itself as being the noun, the methods are what they do. What we've included here is simply the toString and the equals method. Now you may notice that we did not put accessors and mutators inside of this UML class diagram. And for the most part, those methods are ignored. For simplicity's sake, we just leave those out, but we will be developing accessors and mutators for each one of these instance variables. Now you may also notice that we have a plus sign there. This indicates that the scope is public, and the way that we would read this is public return type string, toString, no parameters, and public boolean equals a taco. So now we have created the first class in our UML class diagram. But we need to start recognizing that there are more than just one noun involved in creating this software. Another thing that we need to start recognizing is we need to manage a collection of these. Well, that feels like a separate thing. If we are managing these tacos, then why not create another noun, another class called a taco manager? Now, what properties is this taco manager going to have? Well, it's first going to have a collection of tacos. So, private taco array called tacos. Now, there's another property, and this one is public, and it's type int. But notice that it's underlined, and it's all caps. This indicates this property is a constant value. This constant value is going to represent the default size of this array. As we know, the size of an array is fixed in memory, so it's a good idea to create a default size, as later on we're going to be creating a default constructor. Now moving on from there, we need to think about the methods. We need to think about the verbs that this taco manager is going to do. Well, as mentioned before, we should be able to add tacos, remove tacos, print the tacos, and sort the tacos, which we have represented here. Now the way that we read this is public void add taco given an instance of a taco, public void remove taco given the taco's name, public void print tacos, and oh, hold on a second. This method has a minus. This is private void sort tacos. Now, why would we make a method private? Now, this is a design decision that we're going to discuss a little bit later on. However, when we start developing this software, we need to really start considering what these methods do and whether or not they're going to be used outside of these classes. We need to fully consider if making this public even makes sense. And also, here's another method that wasn't described before, but this is public init. This is short for initialization, returns void, and takes an integer value. This is going to be utilized from the constructors, and that's going to be discussed a little bit later on as well. So now we have these two classes. Well, what is the relationship between the two classes? We have the stick arrow that indicates an association, the has a relationship. And what this says is the taco manager has 0 to many instances of tacos. And we can easily see that because we have a collection of tacos right here, this taco array. Now what we have developed so far, I would consider this to be the back end. This is all of the functionality that we're going to be using to solve this problem. However, we still need to create a simple and easy to use interface, and once again, that feels like a separate noun. So this is where we introduce the Taco Manager FE, the front end. Now this is how the user is going to interface all of these actions for this Taco Manager. Now notice, its properties are all underlined. This means they are static. So we have private static Taco Manager, called Taco Manager, and private scanner keyboard. Then from there we have our methods, which are all static methods. The main method, this method called print greeting, print choices, add taco, and remove taco. All of this is how the user is going to use the back-end functionality. So this method add taco is going to use the add taco method from our Taco Manager, and same thing for the remove taco. The only difference is this is going to provide the interface in which the user can now use this software. Now that we have designed our software, we now move on to implementation. As we have here, we have the project set up and ready to go, and now we need to start creating the classes. So with our design, what is the first class that we need to create? There's a little bit of a trick, but if you follow the arrows, it should indicate where we need to start. The front end points to the Taco Manager, and the Taco Manager points to the taco. This means we should start with the taco itself. And what we're going to do is follow those steps in order to create this class taco. First, we're going to define the class. We're going to create a new class, and we're simply going to call it taco. I'm going to write my name at the top. And now we've taken care of step 1, where we have defined the class. Next, we get to step 2. We need to create the properties. Now, this class had the string name, string location, and double price, which the scopes were all private. Private string name, private string location, and private double price. Next, we create our constructors. I'm going to create one default and one parameterized constructor. Constructors follow a very simple formula. Public, they do not have a return type, and the identifier has to match the identifier of the class, taco. Now, as we have no parameters inside of here, this is our default constructor. The idea of a default constructor is to create an instance, to construct a new instance of this class inside of memory, while also setting all of its properties to default values. So I'm going to set this.name is equal to this.location is equal to none. And yes, I'm able to do it in this way because first we assign location to none, then we assign name, which is the same thing as location, to also being none. Now I'm going to set this.price is equal to 0. And now we have this default constructor that sets all of our instance variables to default values. Next, we create a parameterized constructor. It's recommended that we include a parameter for each one of the instance variables. So public taco, so we need string AN for A name, string AL for A location, and double AP for A price. Now we're not going to fill this out yet, but we're going to add a to-do, call mutators, and we'll get to those in a little bit. Now after we created our constructors, we need to create accessors for each one of the instance variables. These are methods that provide access to this data from outside of this class. They are extremely formulaic. Public, now the first one we're going to write is for string name, so we need to return type string, get, what is the identifier, name, and we have no parameters because we don't need to give it information because we're getting the information. From there, we return this.name. Next, we need to write one for location. So public string get location. From here, return this.location. Now we need to write one for price. Public double get price. Inside of here, return this.price. Simple enough. Now we need to create mutators for each one of the instance variables. Mutators are special kinds of methods that allow us to modify the data inside of here. However, the most important part of a mutator is we do error checking. We want to make sure that the information being set inside of here makes sense. Mutators also are very formulaic. Public void set. We're first going to create a mutator for the property name, so set name. Now we need to have a parameter because we need to give that information. So in other words, what name are we setting this to? This one. Now, as strings are class types, we want to make sure that they are not null. If an is not equal to null, then we could just set this.name is equal to an. But if it was, we need to set this.name is equal just to the default value none. The reason why we're checking whether or not this is null is we don't want to inadvertently run into any type of runtime errors like a null pointer exception. So before we set this name, we're going to guarantee this name even exists. And we're going to do the exact same thing for the location. Public void set location, string al. Now if al is not equal to null, this.location is equal to al. Otherwise, this.location is equal to none. Now finally, we need to set the price. Public void set price, double AP. Now we need to error check if a price that we're trying to assign it to is at least greater than or equal to 0, then we consider that to be correct. This.price is equal to AP. However, we don't consider negative values to be correct, so we're just going to set this to the default value of 0. And now we've written all the mutators. The next thing that we should do is go back to the parameterized constructor and make sure that we call this.setName is an, this.setLocation is al, and this.setPrice is ap. Now, with this parameterized constructor, we can both construct a new instance of this type taco while also setting all of its properties at the same time. Now, the reason why we're using the mutators is because they do the error checking for us. We've already written the error checking once inside of these methods, so why not just reuse the methods? Scrolling down. Now, the only other methods that we need to write are the toString and the .equals method. ToString is very formulaic. Public string toString. And we're just going to return a string with all the properties concatenated together. So we're just going to return the string name plus its name, plus the string location plus its location, plus the string price with the price. Easy enough. Now we need to write the .equals method. The purpose of the .equals method is to compare the contents of this taco versus another taco. So public boolean, true or false. Does this taco equal AT, another taco? Now we're just going to use a compound boolean expression. We're first going to return AT is not equal to null. So if this parameter is null, that means we're trying to compare this taco to nothing. Well, we already know that's false, so we can stop right there. But if it's not null, now we have to check all the properties. Like for instance, this.name. Name is a string type, and we need to use its .equals method in order to compare this name versus a taco's name. Now, how do we get that taco's name? We access it through the accessor, so we get the name. And this .location, we do the same thing. .equals. A taco.getLocation. Does this location equal that location? And then finally, this.price is double equal to at.getPrice. Now, as the type double is a primitive type, we can use the double equals here to compare this price versus that price. So now that we've done all that, we've created the first class in our software, and we're following this design still. Now the next thing that we should write is the taco manager. The purpose of the taco manager is to maintain the collection, in other words, maintain the array of tacos. However, you're going to notice that we're going to change up some things from those 7 steps, because now we need to really start critically thinking about why are we writing each one of these methods, or why are we defining properties in this way? So first, let's keep it simple. Let's define the class. We're going to create the class Taco Manager. I'm also going to put my name at the top. Now the next thing that we need to do is write the properties. The first one is the instance variable that was described in our design. We have a collection of tacos, so a private taco array that we call tacos. Now another property that we have was a constant value. So we create a public static final int default size, and I'm just going to assign it arbitrarily to the value 10. Okay, so far nothing has changed, and the next step is we're going to create the constructors. One is going to be a default constructor, public taco manager, and it's a default constructor which takes in no parameters. Now, I'm not going to write anything inside the body of this constructor quite yet, because now I'm going to address the parameterized constructor. So we're going to start out public taco manager. Now, normally what I would do is I would create a parameter right here for each one of the instance variables. Now, we only have one instance variable, this collection of tacos. But hold on a second. The entire purpose of this taco manager is to maintain this collection of tacos. The more that I think about this, the more that I do not want an outside taco array to modify my internal taco array. The thing is, we're going to carefully structure this data in such a way that we can make this more efficient. We do not want to give the ability for an outside class to modify this information. Again, the whole purpose of this was we were going to maintain this collection by adding and removing these tacos. We should be able to structure our data the way that we see fit. Now the thing is, even though we're not going to create a parameter that's going to be a taco array inside of here, I do recognize that there might be a parameter that we could use. As we know, an array is not resizable in memory. In fact, when we construct an array, we need to provide the size first. So while I'm not going to allow another taco array to take place of this one, I am going to use the parameter int size. That way, we can define the size of this taco array, but not define the elements. Now moving on, I'm now going to create the method init, public void init with an int size. Init is short for initialization, and simple enough, this is going to be called by our constructors to initialize the data. And just like before, I need to error check. So this size could be incorrect. So if the size, now we're going to consider this to be the correct one. If the size is greater than or equal to at least 1, then we can construct this array. Tacos is equal to new taco given this size. Yet, if this size is 0 or something less than 0, which is just not correct, then we can at least use the default size. Tacos is equal to new taco with the default size. Now, from our constructors, we're going to call init. This one, as the default constructor, is going to pass in the default size. And the parameterized constructor is going to pass in its size to be set. To reiterate, we made the design decision to not have this parameter be an instance of another taco array. We did this only because this taco manager is supposed to maintain this collection of tacos. We do not want to provide modification to this outside of the methods that we're about to write. So in other words, if a class wanted to modify this array, if another class wanted to add a taco, then it needs to use the method addTaco. If an outside class wanted to remove a taco by the name, it should use the method removeTaco. We are going to structure this in a very special way. That way we keep everything efficient. And in order to do that, we have understood that we need to safeguard this information. And in addition to that, we are not going to write an accessor or a mutator for this. The only way they can modify, the only way they can mutate this information is through the methods add and remove taco, because again, we're going to structure this array in a very specific way. But before we do that, we need to recognize that, wait a second, this is an array of a class type. Well, how does that even work? So first of all, arrays are considered a special kind of object in Java. An array of object is just an array of memory addresses. Now remember this, every time we've been creating a new instance of a class that we call an object, its identifier only holds a reference, a memory address. This is no different inside of arrays. The arrays only contain the reference to the object itself. Now, if we also remember back, arrays are considered class types inside of Java. So in fact, the identifier tacos will only hold a memory address that refers to the collection, the array of tacos. The default values for object arrays are considered null. So you'll notice here that each one of the taco elements has the null memory address. Now, let's see how this works. Let's assume that the default constructor was called. So inside the default constructor, it calls the method initialization, and it's going to initialize this array to tacos of size 10. Once it constructs that, it constructs this contiguous block of memory of these memory addresses. Now let's just assume that this first element is here, and this memory address is going to be assigned to the identifier taco, and effectively, this points to right here. Now once again, the purpose of the taco manager is so we can maintain this collection. We can only add tacos through the method addTaco, and we can only remove tacos through the method removeTaco. We are not creating accessors or mutators for this instance variable because we want all of the actions to be facilitated through the methods themselves. Maintaining this data is important, and we want to make sure that we maintain it in the way that we best see fit. So with that being said, the way that this taco array is going to be structured is as followed. We're going to keep all constructed objects to one side of it. There are going to be no null elements between all of the constructed objects. When we encounter the first null element, that means every element after that is also going to be null. So as a quick demonstration, if we're going to be adding elements into this array, we're going to start from the first index. From there, we're going to find the first null element. And once we find that null element, we assign the value there. So if we're going to add the first element into this array, we start at index 0. And notice index 0 is already null. So then, as we reach that first null element, all we need to assign is the memory address of that taco, which let's just assume it's 86. Now let's add another taco into this array. Well, starting at index 0, that's not null. So then we move to index 1, which is null, and then we assign it to the memory address, and let's just assume that it's at 283. Now, if we're going to add another element into this, well, index 0 is not null, index 1 is not null, but index 2 is, and so we add it there. Now, the thing that we recognize, if we assume that we have index 3 right here, we know that value is null. We also understand that we're keeping all of the constructed objects to one side of this array. So in other words, this element right here cannot be null. At index 3, that's our first null element, and everything past that indicates that everything is null. Now that we understand how we're going to structure this data, let's go ahead and add the method addTaco. Now back inside of our code, we are going to create public void addTaco. What taco? Well, taco at, a taco. Now just like a string, we want to make sure that we're going to add a taco that exists. So the first check is if at is equal to null, which means this parameter doesn't exist. We're just going to return. Now notice I'm not returning a value. This is because we have a void return type. And in this case, we can simply use the reserved word return to simply stop the method. Now there is another consideration. As we know, arrays have a fixed size in memory. And in fact, what we could have is we can exhaust all of the elements inside the array. In other words, the array could be full of tacos where we can't add another one to it. Well, how can we tell if this array is full? We can do this in a number of ways. However, by structuring our data in the way that we did, by keeping all of the constructed elements to one side of it, we can make this very simple. So if tacos, now let's look at the last index. Tacos.length -1. Now this is the last valid index, and if that last valid index is not null, we need to also return. As we were keeping this all to one side of the array, if the last element inside of this array is not null, that means everything before it is also a taco. There are no null elements. Now this makes this check very efficient. And this is why we should carefully consider how we structure our data. That way we create more efficient programs. Now, if neither of these are true, that means there has to be a space available. So now we need to find it. The best friend of an array is still a for loop. For int I is equal to 0, I is less than tacos, dot length, I++. Now once again, the array of the class types are array of memory addresses. So if we find an empty memory address, in other words, if tacos at index I is equal to null, that means there's an empty space in our array and we've encountered the first one. This means everything after this element is also null. However, what we're going to do is now assign tacos at index I to the memory address that is held inside of this parameter, at. And after that, we break. The reason why we need to break this loop is so that we don't add the exact same memory address to all of the elements inside the array. When we find the first null element in this array, we simply assign the memory address that refers to that object to our array, then we break. So then after that, we're going to get to this later, but we're going to call to do sort. So every time we add a new taco, we're also going to sort the entire array by the price. Now we're not quite done with this very long example, and we're going to finish this up in the next lecture. The next time, we're going to go over how we can remove elements, how we can then sort the elements, print out the elements, and also create the front-end interface. And until then, I'll see you next time.